Welcome everybody. It's Ramachandra from Civil Mech Maths Concepts, and today I will be discussing on integral calculus 5th lecture on Leibnitz rule. Leibnitz rule can be used for finding the definite integrals very easily using the partial differentiation, and differentiation of integral is equal to the integral of partial differentiation of the function, and if the functions are constants, the limits can be constant or limits can be functions of the variables under different conditions. As per the Leibniz rule, the definite integral is calculated and all are explained in this particular video. And in this video, I have in detail explained everything, and in the next video, I will be explaining about the mathematical modeling, and I will be starting the ordinary differential equations. Then I will move on to partial differential equations. Integral calculus 05 is my 14th video in the series of engineering mathematics. Please view it till the end, review and comment, so that as per your comments, I'll try to improve upon the videos. And also, if you like my video, please like it and subscribe to my channel. Get Civil Mech Maths Concepts. I am an IIT Alumni and I welcome everybody to listen to my video. Please take the concepts which I have explained in this video and use them in the examination to score high. Best of luck to everybody. Thank you for listening to me. Civil Mech Maths Concepts welcomes you for this video. Welcome everybody. It's Ramachandra again from Civil Mech Maths Concepts channel. In this video, which is called as Integral Calculus Lecture number 5. Integral Calculus Lecture number 5. In this, Leibniz rule will be discussed. In detail. In total, Leibniz rule discusses about the differentiation of an integral function. Let us say a function u is there. It is a function of p, up, and another function v is there, which is a function of variable p, and another function is there of fxp. Then, as per Leibniz rule, differentiation with respect to p, d by dp of integral up to vp. It is a general Leibniz rule valid for any kind of function. Whether an integral involves the variable p and the limits involve variable p in the form of functions from up to vp as lower limit to the upper limit, and any function xp, then dx, this is the integral, this will be equal to integral up, lower limit is up, upper limit is vp, dou by dou p partial differentiation with respect to p of function xp dx plus v dash. Here v dash is nothing but dv by dp, because v is the function of p. V dash is equal to dv by dp. V dash p function of vp and p minus u dash p function of up p. Please try to understand each and every item of this function, of this Leibniz rule, because in any mistake in understanding the limits or the differentiation or the integration will lead into wrong answers. Let us say, if it is too much complicated, looking like too much complicated, can we say UP as U? But remember, whenever you are talking U as a function of some variable, the function of some variable, that variable is P. That variable is P in Leibniz rule. Because you are finding the derivative of an integral of some function xp dx with respect to dp, then we are getting, that is on the left hand side, we are getting the right hand side. You just see on the left hand side, it is like this: d by dp, a function of up to function vp. These are all variables. These are not constants. And we can even simplify this Leibniz rule into the form of limits as constants also. That is in the next step I will show. This is a general form of Leibniz rule, where up is the function of p, vp is the function of p, whereas up is the lower limit of the integral, vp is the upper limit of the integral, and function xp is given integral up to vp function xp dx, that is the basic integral on the left hand side, and we are differentiating with respect to the variable p. And here, what is v dash? V dash p is nothing but dv by dp of v of p. U dash p is equal to du by dp. Usually we have a thinking that once v and u are given, we say that u is nothing but function of x and v is nothing but function of y. Function of x or y. That I want to differentiate by keeping the variable in the brackets. If you are very clear that up is equal to some function of p and as lower limit of integral, and vp is equal to some function of p as upper limit of integral then we can simplify UP, let us say we call it as U. Here please remember that U is not the function of X. And VP, let us say, these are all only a matter of nomenclature, nothing to worry. VP is equal to V is a function of P. In this particular Leibniz rule, let us say. Then how can we write the Leibniz rule? D by dP of integral U to V function of xp dx is equal to integral U to V. These U and V are the variables, functions of a variable P. They are not constants. Dou by dou P of function of xp dx plus V dash. I have removed the bracket P for simplification. Function Vp minus U dash into function Up. This you kindly remember this formula. This is the Leibniz rule. This some people say they will only talk about when variables are given, they only talk about V dash F Vp minus U dash F Up. They don't write this value because dou by dou P of xp is treated as 0. Because some function of xp, let us say, for example, please try to understand this. Function of xp, let us say, it's nothing but 1 by tan x into e to the power of minus tan x into ln 3 minus x, let us say, some function xp. Then what is the value of dou fxp by dou p? Here, because there is no term of p in this, we will say dou function xp by dou p is equal to 0. This all depends upon what is function xp. But people, some tutors, they take this dou f xp by dou p as 0 and they eliminate this step and directly go for v dash f vp minus u dash f up. Don't go like that. Just understand the basic, write the whole equation, then wherever zeros are there, you make the zeros and then find the value. Don't just jump to the conclusions without understanding the original function. And everything is okay. Even my way of teaching is also okay. Other tutors are also okay. But only thing is that why it has come like this. This is the reason why people have taken only second function derivative into something minus first function derivative into something. That's how they are in a simplified manner. But the original equation is d by dp of integral from u to v function xp dx is equal to integral u to v dou by dou p of function xp dx plus v dash f vp minus u dash f up. This is the real full equation. Now in this, you go on substituting the values, get the values, and then you understand how the problems can be solved. And often this Leibnitz rule is directly or indirectly is used in solving certain problems in IIT Advanced Mathematics, JEE Advanced Mathematics, or some simple questions are being asked in JEE Mains Mathematics also. JEE Advanced Mathematics, some good questions are asked on Leibniz rule. One of the questions I will solve today. And once you understand this problem, once you understand this Leibniz rule clearly, then we'll go for solving the questions. I will take up a very simple problem and let me see whether our understanding goes well. For example, my original equation is d by dp integral u to v function xp dx is equal to integral u to v dou by dou p function xp dx plus v dash f vp minus u dash f up. For example, my u and v, their limits are constant. If the limits of the integral are not functions of p but are constants, then what happens to the original equation? U is equal to some constant, V is equal to some constant. This can be integral limits. Lower limit can be 0 to 3, 0 to 5, 0 to pi, 0 to pi by 2, depending upon the question that is given in the examination. Then what will be the value of u dash? U dash is equal to 0, v dash is equal to 0. Then what happens to the original equation of the Leibniz? I am only talking about the original equation of the Leibniz. Then the original equation of the Leibniz that will become, if u and v are constants, then that will become d by, original equation is d by dp of, please, it is a very important step, integral u to v function xp dx is equal to integral u to v dou by dou x function of xp dx plus v dash into function of bp, please follow me, minus u dash into function up. If u and v are constants, if u and v are constants, u dash, v dash is equal to u dash is equal to 0, the derivative of a constant is a 0. That implies the Live energy will be d by dp of integral u to v. They are not functions now, they are constants. Function xp dx is equal to integral u to v. U and v are constants. Please remember, dou by dou. It is not dou by dou x, sorry, it is dou by dou p. It is dou by dou p of function xp dx plus 0 minus 0. When the limits of an integral are constant, then the Leibniz equation will be d by dp of integral u to v function xp dx is equal to integral u to v dou by dou p of function xp dx. For avoiding the confusion u and v, let me say the constants are a and v. Let u is equal to a and v is equal to b constants. Then Leibniz rule will be integral a to b d by dp of integral from a to b function xp dx is equal to integral a to b dou by dou p of partial integral of function xp with respect to p into dx. If limits are constant, the Leibniz rule should be written like this. If the limits are variable, the Leibniz rule should be written in this way. Until and unless dou by dou p of function xp is 0. In the example which I have given here, dou by dou p of function xp is equal to 0. It's an example only. It's not always 0. Please try to find out the condition under which the question is asked. The conditions are like this. 1. U and v are functions of p and dou by dou p of function xp is not equal to 0. Then use the full formula. 2. If u and v are functions of p but dou by dou p of function xp is equal to 0, then use truncated formula. Third, if u and v is equal to constants, use simple formula. What is the full formula? Full formula is equal to integral. Full formula is d by dp of integral up to vp function xp dx is equal to integral up vp dou by dou p of function xp dx minus v dash p function vp p plus it is minus u dash p function up p. Second is, what is truncated formula? Dou by dou p of function xp is equal to 0. That says d by dp of function u to v. These are variables of p. I am just taking out p for simple appearance, aesthetics purpose. That is equal to, this is 0, hence v dash function vp minus u dash function up. Then simplest formula, third is simple formula where u is equal to some constant, v is equal to some constant, then that involves integral some constant u to v d by dp of function xp dx is equal to integral u to v dou by dou p of function xp dx. These are the three conditions under which we can apply the Leibnitz rule, and depending upon the question given, we can easily find out. You just see the beauty of this Leibnitz rule. For example, a particular integral is given for which it's a definite integral, improper integral. The regular processes of solving it are not yielding any result, or very tough to yield any result. Then in that case, what we can do, we can find out from right hand side. Please try to understand this application of Leibnitz rule. This is the right hand side, this is the left hand side. The right hand side, partial differentiation of function xp with respect to p is very easy to do. It's not a complicated one. You do that, apply the limits, given limits, and find out the integral. this will be equal to the differentiation of the total integral given. Let us say d by dp of some given integral in the question with respect to x is equal to, please, it is very important, it's not written in any book, integral of partial differentiation with respect to x, with respect to p, sorry, not x. Limits are same. Here also limits are same. These are constants, let me say. That means once you have got the differentiation of the given integral, then what is the value of the given integral? This is nothing but integral of this value. Therefore, answer of given integral is equal to, please see the beauty, integral of, this is left hand side, integral of uv partial differentiation with respect to p dx and dx. You just see. If a definite integral you are unable to solve, how to get the answer of it? You do the partial differentiation with respect to some given equations, whatever, with respect to p, and then do the integration of it, and again do the integration of it, that will give the given integral value. I think you understood this process. I will give on the application, once you understand the real application of the Leibnitz equation, instead of solving the problems just like that, some values are given, I will substitute. No. Let us apply it and find out how to solve the tougher, most improper integrals in the definite integrals process using the Leibnitz rule. Let us solve one simple question which involves our final assumption to get an answer for a given integral. For example, a question is like this: find the value of the integral 0 to 1 x to the power of p by ln x dx. This is the problem given. Find the value of the integral 0 to 1 x to the power of p by ln x dx. And let me say, try to apply Leibnitz rule. What the Leibnitz rule says? D by dp. Here, first analyze the given problem. Solution. Analyze the condition. Here u is equal to 0, v is equal to 1. That means u and v are constants. Which formula to be used? If the limits of an integral are constant, we have to use the simple formula d by dp of integral a to b function xp dx is equal to integral a to b dou by dou p of function xp dx. Now here, left hand side, this is the Leibnitz rule. Left hand side, for the time being, let us forget. Let us find out the value of the right hand side. Integral a to b dou by dou p of function xp dx. Here what is a? U is equal to a is equal to 0, v is equal to b is equal to 1. This can be written as 0 to 1 dou by dou p of what is function xp? This is a function of x and p. That is x to the power of p by ln x. Right hand side is simplified like this. This will be nothing but what is the, here x is treated as constant and p is treated as variable in the right hand side. Now, this will become 0 to 1, 1 by ln x into dou by dou p of x to the power of p dx. What is the value of dou by dou p of x to the power of p? X is a constant. Here x is not a variable, p is the variable. Dou by dou p of x to the power of p is equal to x to the power of p into ln x. This is the value of derivative of x to the power of p. Now by substituting this value in the right hand side equation, we will get right hand side is equal to integral 0 to 1, 1 by ln x into x to the power of p into ln x dx. That will be ln x will get cancelled and it will be integral 0 to 1 x to the power of p dx so x to the power of some constant something dx is nothing but x to the power of p plus 1 by p plus 1, the limits ranging from 0 to 1 because limits are constant. Then what will be its value? One to the power of p plus 1 by p plus 1 minus 0 to the power of p plus 1 by p plus 1. That is equal to 1 by p plus 1. Do you agree? Right hand side is equal to 1 by p plus 1. And what is the left hand side? Left hand side is equal to d by dp of the given function. What is the given function in the examination or question? Given function is 0 to 1 x to the power of p by 1 plus x dx. Differentiation of the given function with respect to p is equal to 1 by p plus 1. That implies integral 0 to 1 x to the power of p by 1 plus x dx is equal to integral of 1 by p plus 1 dp, that is equal to ln p plus 1 plus some c. Very simple. We solved it. We have not integrated the real function here. Please try to understand. This is the beauty of Leibnitz rule. That means without differentiating the given function, without integrating the given function, by using the Leibniz rule, applying the partial differentiation rules, partially differentiating the given function with respect to the p, and integrating the given obtained value from the partial differentiation, we will get the differentiation of the given function. Then by reintegrating, we will get the final answer for the integration. That means here at any point of time we have not integrated the given function. That means if the given function is an improper integral, definite integral, in that case we need not integrate and solve it. We can go with the help of Leibniz rule and find out the value of the given integral. First by differentiating with respect to p, partial differentiation. Then after obtaining that result, you integrate it, the result, then you will get the final integration value. At no point of time we are not integrating the given function, so that we can get the value of the definite integrals in this manner without directly integrating them using the Leibniz rule. Now we'll take up, on the basis of this, we'll take up one question from IIT JEE Advanced Mathematics. Not only in IIT JEE Mathematics Advanced, this type of questions are asked in GATE, JAM examination also, in GATE examination, and also in CSIR. Let us solve one typical question from JEE Mathematics Advanced, so that you will further get a clarity on how to use the Leibniz rule in the examination and get the solutions in seconds. Now, let us solve one typical question asked in JEE Advanced Mathematics in 2023. That question is, find FE if F1 is equal to 1 by 3 and 3 into integral ft dt for the limits from 1 to x is equal to x fx minus x cube by 3. This is the question given. Here, you just analyze left hand side what it is given. 3 into integral 1 to x ft dt. In this, the function u, lower limit is constant, the upper limit is a variable with respect to x. Then we can say, from the knowledge we acquired from the Leibnitz theorem or Leibnitz rule, we can say u is equal to 1, a constant, v is equal to x, which implies u dash is equal to 0, v dash is equal to 1. And second thing, let us differentiate the left hand side function with respect to dx. Because here variable limits are x terms, we have to write d by dx. In the previous questions, what we have done, the u and v are functions of p. Then we made it as d by dp. Here u and v are functions of x. Hence we have to write as per Leibniz rule, as the limits are functions of x, we say d by dx of the left hand side is equal to integral of, what is that? Here variables. Here the functions are, the limits are variables. Then what we have to use? The general formula. D by dx of left hand side is equal to integral 1 to x dou by, instead of dou by dou p, we will write dou by dou x, because limits are in terms of x, into function t dt plus v dash, instead of v dash p, we will write v dash x, because it is function, the limits are the functions of x. Function of vx x minus u dash x into function of ux x. Wherever p is there, we have taken it as x, and wherever x is there, we will replace it with t. Here it is t. Now you just see what happens. Integral of dou by dou x of function t dt. In function t dt there is no x term. When you see in the left hand side, forget about the right hand side, whatever given in the problem, then this value will become 0. Then what is the v dash x? It is 1 into, what is vx? X. Function xt. Function xt is nothing but function x. We have to multiply with 3 because left hand side is multiplied by 3. Here we need not write because left hand side we have already written here. This is multiplied by, this is multiplied by 3. This u dash is 0, hence it is 0 minus 0. Then this will be 3 into function x. That means d by dx of left hand side is equal to 3 into function x. This is the most important value which we have got from Leibnitz theorem. This is the heart of the solution. Then in the last just a few minutes back what I have told you, to find out the value of the given integral we have to reintegrate this value. That means d by d, what we have got from Leibniz rule, d by dx of left hand side is equal to 3 into function x. Please try to understand the steps. Very, very, very important. As per Leibniz rule, as the limits are functions of x, because one is function of x, that is v is equal to x, u is equal to 1 is constant, u dash is equal to 0, v dash is equal to 1. As per Leibniz rules, whatever the variables in the limits, that variables with respect to that we have to take the derivative d by dx of left hand side, because x, v is the function of x, u is also function of x. Then that is nothing but 3 into this whole value, 3 into fx. This is all. Because dou by dou x of ft dt is 0, v dash x is equal to 1, and f vxt is nothing but fxt is nothing but fx, and u dash x into f uxt, that is 0, then 3fx. d by dx of left hand side is equal to 3fx. Now, the given problem can be now written as d by dx of we have to write d by dx of left hand side is equal to 3fx integral of 3 into left hand side is equal to 3 into integral of 1 to x function t dt is equal to integral of 3 function x. Just integrate. By integrating, we will get left hand side is equal to 3 into integral of 1 to x ft dt. That is the left hand side. This is what is left hand side. This whole is left hand side. This is equal to, because this value 3 into this left hand side is equal to 3fx, we will integrate 3fx from 1 to x, whatever you call it. Now, you just see. This is nothing but 3 into integral of fx dx. That means I can write the left hand side as 3 into integral of fx dx, that is equal to what is that? X fx minus x cube by 3. That's what is given in the problem. Now let me differentiate. If I differentiate, what happens? By differentiating, what happens? Fx dx, 3 into fx dx is equal to x into f dash x plus fx. Apply the UV formula. For x fx is nothing but x into f dash x plus fx into 1 minus x square. Differentiation of x cube by 3 is x square. This implies fx is there, then you take everything on one side, x f dash x minus 2fx is equal to x square. That implies x is equal to f dash x minus 2 by x into fx. Then what happens? It is an ordinary differential equation which can be solved very easily, or else we can even write it as x into dy by dx minus 2y is equal to x square, where y is equal to function of x. This is a simple ODE, ordinary differential equations, from which we can find out the value of y, and already f1 is given as an initial value problem. f1 is equal to 1 by 3, and we have to find once to find fe. This is the initial value. Initial or given value, boundary condition, and this resolution of this is given as solve x dy by dx minus 2y is equal to x square as homework, and apply BC for f1 is equal to 1 by 3 and get the value of fe, that is equal to y of e. This you take it as a homework. Main heart of the problem is application of Leibnitz rule, which I have done, and it's very, very, very important to note that the general Leibnitz rule is to be understood. From there, from the given intervals, we have to find whether the intervals of the integration are constants or variables. If they are the variables of x, we have to differentiate with respect to x. If the variables are p, we have to differentiate with respect to p. If the variables are t, then we have to differentiate with respect to t. From that, from the given problem, we will arrive at one particular differential equation. That differential equation, if it comes in the general differential equation like ODE in this problem, we can solve it and get the values of function for the given conditions. This is how Leibniz rule is to be applied. Because today's lecture is little bit long, more than the thought over Leibniz rule, I have taken little more time for explaining this in detail so that you will understand all the three conditions. One is general rule, second is variables either constants, both the variables are constants. Third, this what you call a simple formula where we can directly use the partial differentiation and get the answer of the integral. This is how we have to use Leibniz rule for solving the improper definite integrals. It's a very simple one. If you start applying for different problems, then you will easily understand the process and you can do it very well in the examination. It doesn't take not more than a minute to solve these problems. If you are thorough in Leibniz rule understanding. Don't go by shortcuts. If it is little bit lengthy also, you practice in home questions, then apply the rule, you put it in your brain, and in the examination when you go with your practice of the Leibniz rule, you can find out the definite integral values very easily. Solve the problems from Civil Services, CSIR, IIT Advanced and GATE, this type of problems, and excel in this Leibniz integral utilization for finding the improper integral values, which are very, very important in the engineering mathematics point of view. Today, I will not be taking the mathematical modeling and differential equations as I told you earlier. This class for Leibniz integrals I have dedicated. In the next class, I will start with the mathematical modeling, and in the mathematical modeling, we will start with differential equations. Next class, I will go for mathematical modeling. This is very, very important. Mathematical modeling. With ODEs and PDEs. ODEs ordinary differential equations and PDEs are partial differential equations. Then we will move forward to Fourier transformation, Laplace transformation, and we will slowly conclude our calculus. Best of luck to everybody. It's Ramchandra again. If you like my video, please comment for further improvement. And also, if you feel my videos are useful to you, kindly subscribe to my channel Civil Mech Maths Concepts so that you will get the updated videos, regular updations on my videos to you. Don't be afraid. GATE examination is a examination which tests your basic knowledge on the concepts rather than complex questions. These are all basic knowledge which you require. These are all the concepts. And once we move into the complex variables, you will understand the importance of all these things. Almost maybe after some, once I complete the calculus, I will move on to maybe in a week or two, I will move on to complex variables and complex integration, where these are all things you apply and you feel that these are all things very preliminary when you go into the level of understanding the complex integrals, contours. Best of luck to everybody. It's Ramchandra again. I am an IIT alumni. I would like to help you all for better understanding of the engineering mathematics, and also not only for GATE, for CSIR, UPSC and IIT. Best of luck once again.